I'm Principal Sheep. Welcome back to our classroom. Today, I'll be teaching you about particle theory and pressure in gases. What is the particle theory? The particle theory explains the properties of matter based on the idea that all matter is made up of tiny little particles, atoms, or molecules that are constantly moving. The key ideas for particle theory. All matter is made of very teeny tiny particles. These particles are in constant random motion. There are small spaces between the particles. There are forces of attraction between these particles. These forces are stronger in solids, weaker in liquids, and very weak in gases. The temperature of a substance is a measure of the average kinetic energy of motion, of its particles. The higher the temperature means the particles move faster. Gases and particle theory. In gases, the particles are far apart compared to liquids and solids. They move randomly and at high speeds. The forces of attraction between gas particles are very weak. Gas particles collide with each other and with the walls of their container. Pressure in a gas is defined as the force exerted by the gas per unit area on the walls of its container. How particle theory explains gas pressure. Gas pressure is caused by the countless collisions of the rapidly moving gas particles with the walls of the container. Each collision exerts a tiny force on the wall. The combined effect of these numerous collisions over the entire surface area of the container results in pressure exerted by the gas. This is why when you buy a soda can and you don't open it, it feels hard. But when you open it, some gas escapes and it feels soft. Some factors affecting gas pressure. The pressure of a gas can be affected by several factors. The temperature. Increasing the temperature of a gas increases the average kinetic energy of its particles. They move faster and collide with the walls more frequently and with greater force, leading to a higher pressure if the volume is kept constant. Volume. Decreasing the volume of a gas forces the particles closer together. They collide with the walls more frequently, resulting in a higher pressure if the temperature is kept constant. Number of particles. Increasing the number of gas particles in the container without changing temperature or volume means there are more particles colliding with the walls, leading to a higher pressure. The relationship between pressure and volume at a constant temperature. If the temperature of a gas remains constant, the pressure of the gas is inversely proportional to its volume. This means that if you decrease the volume, the pressure increases, and if you increase the volume, the pressure decreases. Mathematically, this relationship can be expressed as P1 times V1 equals P2 times V2 equals constant. P1 is the initial pressure. V1 is the initial volume. P2 is the final pressure. V2 is the final volume. Why? When you decrease the volume, the gas particles have less space to move in, so they hit the walls of the container more often, increasing the pressure. Now, I'll give you an example. Imagine a gas in a container with a volume of 2 meters cubed and a pressure of 100 pascals. If you compress the container to a volume of 1 meter cubed while keeping the temperature constant, what will the new pressure be? Using this formula, P1 times V1 equals P2 times V2, 100 pascals times 2 meters cubed equals P2 times 1 meters cubed. So P2 must equal 100 pascals times 2 meters cubed divided by 1 meters cubed, which is 200 pascals. The new pressure will be 200 pascals. The relationship between pressure and temperature at a constant volume. If the temperature of a gas remains constant, the pressure of the gas is inversely proportional to its volume. This means that if you decrease the volume, the pressure increases, and if you increase the volume, the pressure decreases. Mathematically, this relationship can be expressed as P1 over T1 equals P2 over T2, which equals constant. P1 is the initial pressure. T1 is the initial absolute temperature, which means that the temperature has to be measured in Kelvin. P2 is the final pressure. T2 is the final absolute temperature. An important note is that you must use the Kelvin scale for temperature in these calculations. To convert Celsius to Kelvin, you have to add 273 to the degree of Celsius. Why? Increasing the temperature increases the average speed and kinetic energy of the gas particles. This means they collide with the walls more forcefully, leading to a higher pressure. Now, I'll give you an example of pressure and temperature. A gas in a sealed container has a pressure of 150 kilopascals at a temperature of 27 degrees Celsius. If the temperature is increased to 127 degrees Celsius, what will the new pressure be? First, convert the temperatures to Kelvin. The first temperature is 27 plus 273, which is 300 Kelvin. The second temperature is 127 degrees plus 273, which equals 400 degrees Kelvin. Now, use the formula P1 over T1 equals P2 over T2. So, 500 kilopascals over 300 Kelvin equals P2 over 400 Kelvin. So P2 must equal 500 kilopascals times 400 Kelvin over 300 Kelvin, which equals 200 kilopascals. So the new pressure will be 200 kilopascals. Now, I'll give you a few questions to test how well you understood this lesson. Question 1. A balloon contains a gas at a pressure of 105 kilopascals and a volume of 5 liters. If the volume of the balloon is decreased to 2.5 liters while the temperature remains constant, what will the new pressure inside the balloon be? The answer is, using the formula P1 times V1 equals P2 times V2, we have 105 kilopascals times 5 liters equals P2 times 2.5 liters. P2 equals 105 times 5 over 2.5, which equals 210 kilopascals. The new pressure will be 210 kilopascals. Number 2. A rigid container contains a gas at a temperature of 20 degrees Celsius and a pressure of 120 kilopascals. If the container is heated to 80 degrees Celsius, what will the new pressure be inside the container? Remember to convert these temperatures to Kelvin. To get the answers, first convert the temperatures into Kelvin. T1 equals 20 degrees Celsius, so add 273 to 20, which equals 293 Kelvin. To get the second temperature, it is originally 80 degrees Celsius, and add that to 273, which equals 353 Kelvin. Using the formula P1 over T1 equals P2 over T2, we have 120 kilopascals over 293 Kelvin equals P2 over 353 Kelvin, and P2 must equal 120 times 353 over 293, which approximately equals 144.5 kilopascals. The new pressure will be approximately 144.5 kilopascals. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.